Hey everybody. Today we're doing some more antidifferentiation. We're going to look at a couple of initial value problems. So, an initial value problem is a situation where you're given some information about a derivative of a function and asked to find the original function, but also given a point or points on the graph. So, you don't end up with a general antiderivative, you end up with a particular one. We're going to do one that's just a straight up example where you have a derivative and a point on a graph. And then we'll do one with acceleration, velocity, and displacement. Okay, so the approach in these problems is always the same. You start by getting your most general antiderivative. So for 6 over x cubed, I've rewritten it as 6x to the negative third. I raise the power by 1 to get to the negative second, and then I multiply by the reciprocal of that, so negative a half. Simplifying it a little bit, negative 3 over x squared plus c is the most general antiderivative. Now let's use that fact that f of 1 equals 4. So we're going to want to plug those in. F of x is 4 and x equals 1 to get an equation with just c in it that we can then solve for c. And we get c equals 1. So overall, the function that we need is f of x equals negative 3 over x squared plus 1. Not too bad. Now let's go for this acceleration problem. Remember that acceleration is the derivative of velocity, and velocity is the derivative of displacement. So overall, acceleration is the second derivative of displacement. We're going to do the same thing. Get the most general antiderivative and then solve for c. Here, though, since we've got a second derivative given to us, we're going to have to do it twice. So I antidifferentiate v prime, which is a, and I get velocity is negative cosine t plus 2 sine t plus c as the most general antiderivative. Now let's plug in the fact that v of 0 is 0 to get an equation for c. So remember that cosine of 0 is 1 and sine of 0 is 0. Overall c is 1. So the velocity function, negative cosine t plus 2 sine t plus 1. Wash, rinse, repeat. We need to antidifferentiate to get the most general antiderivative of v. That's going to be s of t. Again, it's got a constant in there. I've called it c2 this time so we don't get it confused with the c up above. Next, we have to plug in our initial condition. S of 0 equals 0. Sine of 0 is 0. Cosine of 0 is 1. So overall, I get c2 is equal to 2. The displacement function overall is s of t equals negative sine t minus 2 cosine t plus 2.